A pleasant day to the future teachers, especially the BSE 2B Mathematics majors of NEUST San Isidro campus. This morning, I would like to welcome you in our discussion for the Unit 2 of the SEM 6 or the Plane and Solid Geometry, which is triangles. This is the part 1 of the Unit 2. So this part 1 will be revolving on the discussion about the definition and classifications of triangles, the Pythagorean Theorem, and the area and perimeter of triangles, while the part 2 of this discussion will revolve on the triangle similarities. So classifying triangles, angle measures of triangles. But before that, let us first define what triangle is all about. A triangle is a figure formed by 3 segments joining 3 non-collinear points. So these are the 3 non-collinear points, and when you join these 3 points, you will be forming a triangle. Another definition of triangle is that it is a plane figure. It is a 3-sided plane figure. So let us classify triangles by sides. Triangles can be classified in 2 ways. The first one is by sides, and the second one is by angles. So the classifications of triangles according to sides are Equilateral Triangle, Isosceles Triangle, Scalene Triangle. So all those 3. Equilateral triangle has 3 congruent sides. If a triangle has 3 congruent sides, then that is an example of equilateral triangle. If this is 10 inches, this is also 10 inches and 10 inches, then this triangle has 3 congruent sides, then that triangle is what we call an equilateral triangle. How about an isosceles triangle? An isosceles triangle has at least 2 congruent sides. So for a triangle to be an isosceles triangle, there should be at least 2 congruent sides. Meaning, an equilateral triangle is also an isosceles triangle because it satisfies the condition of an isosceles triangle. And then the last one is an scalene triangle. An scalene triangle has no congruent sides. So if this is 3, this is 4, and this is 5, then this triangle is an example of scalene triangle. No two sides are congruent. Okay, let us have a practice exercise here. Classify the triangle by its sides. So you will tell me what type of triangle is being illustrated in the figure according to its sides. So whether it is a scalene, equilateral, or scalene. The first figure here, we have 5, 5, and 6. So this is an example of isosceles triangle. Figure number 2, we have 19, 19, 19. So this figure or this triangle is an example of, yes, it is an scalene triangle, but also an equilateral triangle because 3 sides are congruent. Next, we have 6, 8, and 10. What type of triangle it is according to its sides? Very good. This is an scalene triangle. How about this one? 5, 10, and 12. So this triangle is an example of scalene triangle also. Let us now move on to the classification of triangles by angles. So we have 4. The first one is Equiangular Triangle. Equiangular meaning equal angles. Equilateral, equal lateral or equal sides. Then Acute Triangle, Right Triangle, and the Obtuse Triangle. Let us deal with it one by one. Equiangular Triangle has three congruent angles, meaning all angles are congruent. And for a triangle to have equal angles, three equal angles, the measurement of each angle must be equal to 60 degrees. So an equiangular triangle always have 60 by 60 by 60 degree angles. How about an acute triangle? An acute triangle has three acute angles. So that means that an equiangular triangle is also an acute triangle because all three angles are acute angles. But it has a special name because that's very rare. The next one is the right triangle. A right triangle has one right angle. So if a triangle has one right angle, then that triangle is an example of right triangle. So is it possible for a triangle to have two right angles? Yes or no? The answer is no. Because if a triangle has two right angles, then that two right angles, if you sum up, is already equal to 180 degrees. And we know that the sum of all the angles of a triangle is only equal to 180 degrees. So nothing will be left to the other angle. So it is impossible for a triangle to have two right angles. Obtuse triangle. An obtuse triangle has one obtuse angle. So again, the same question with the right triangle. Is it possible for a triangle to have two obtuse angles? The answer is no. By the way, an obtuse angle is an angle whose measure is greater than 90 degrees but less than 180 degrees. So let us classify the triangle by its angles. Let us take a look at here. First triangle, we have, this is an example of acute triangle. Yes, acute triangle, but this is a special one because all the angles are congruent. So this triangle is what we call an equiangular triangle. How about this figure? We have 40 degrees, 20 degrees. These two measurements are acute angles. And this is 120 degrees. So what type of triangle it is according to the angles? Yes, this is an obtuse triangle. How about this figure? We have 78 degrees, 80 degrees, 22 degrees. All the angles are acute angles. So this is an example of acute triangle. So the parts of the triangle. So take a look at this. The triangle is being positioned like this. So B is a vertex. And also a vertex. And C is also a vertex. So all these three are vertices. And line segment BC is opposite to angle A. So BC is opposite to angle A, and angle A is opposite to BC. How about the line segment that is opposite to angle C? What line segment is opposite to angle C? It is line segment AB. How about the line segment that is opposite to angle B? Yes, that is line segment AC. So take note that a vertex of a triangle is a point that joins two sides of the triangle. So that means that in the triangle we have three vertices. The side across from an angle is the opposite side. So with respect to angle B, the opposite side is line segment AC. With respect to angle A, the opposite side is BC, and the other two line segments are what we call adjacent sides. Name the side that is opposite to the angle. angle J. What is the side opposite to angle J? Yes, it is line segment LK. How about the line segment opposite to angle K? Yes, that is line segment LJ. And then the line segment or the side opposite to angle L is line segment JK. The triangle sum theorem. Consider triangle ABC. The sum of the measures of the angles of triangle is 180 degrees. What we are talking about here are the interior angles. The angles that we are talking about are the interior angles. Meaning, if you sum up angle A plus angle B plus angle C, the answer is 180 degrees. Let us find the measure of the missing angle here. Suppose that angle C is 25 degrees, then angle B is equal to 15 degrees. Then using your calculator, we know that the sum of the interior angles of a triangle is 180 degrees. So you start with 180, then subtract the other two measurements. So 180 minus 25 minus 15 is equal to 140 degrees. So that means that angle A is equal to 140 degrees. Okay, let us have this next figure. So we have 61 and 59. So we do the same process. 180 minus 61 minus 59. And that is equal to 60 degrees. So this is 60 degrees. And then for the last figure, we do the same process. 180 minus 56 minus 34 is equal to 90 degrees. So angle B is equal to 90 degrees. Okay, let us classify these three triangles according to angles. So this first figure is an example of obtuse triangle. Then this is an example of acute triangle, and this one is an example of right triangle. The corollary to the triangle sum theorem. The acute angles of a right triangle are complementary. So if we have a right triangle ABC where C is the right angle, then these two acute angles are always complementary. When we say complementary, when you add the two angles, then the measurement is equal to 90 degrees. Yes, of course. Why? Because we know that the sum of all the interior angles of a triangle is always equal to 180 degrees. If the measurement of the other angle is already 90 degrees, then the remaining two angles should have a sum of 90 degrees to get 180 degrees. That is the reason why angle A and angle B are complementary angles. Meaning when you add angle A and angle B, the sum is equal to 180 degrees. In triangle ABC, if measure of angle C equals 90 degrees, then the measure of angle A plus measure of angle B is also 90 degrees. They are complementary. Triangle ABC is a right triangle. Find the measure of angle A. Alright. So this is 90 degrees. So if this is 17, what would be added to 17 to get 90 degrees? So you subtract 90 by 90 minus 17, so you will have a difference of 73. So measure of angle A is equal to 73 degrees. For the next figure, angle B is a right angle. So what would be added to 65 to get 90? So that is 90 minus 65. We subtract. The answer is 25 degrees. So measure of angle A is 25 degrees. In here, angle C is the right angle and this is 45. So definitely angle A is also 45 degrees. Interior angles. So when we say interior angles, these are the interior angles of the triangle. If we extend, when the sides of triangles are extended, other angles are formed. The three original angles are the interior angles. And these are the exterior angles. So the angles that are adjacent to interior angles are the exterior angles. It is common to show only one exterior angle at a vertex. So we extend the sides of the triangle in the same direction to the, this is one. This is the first side, we extend it like this. Then the second one and the third one. So we had the exterior angles of the triangle. We also have the exterior angles theorem. The measure of an exterior angle of a triangle is equal to the sum of the two remote interior angles. And what are the remote interior angles? So take note that in this case, we extended our side AC. So we extended it and we formed an exterior angle here and we named it angle 1. So from the original angle, angle C, this angle C is what we call the adjacent angle of this exterior angle. So the remote interior angles are angle A and angle B. So angle A and angle B. And according to the exterior angles theorem, the measure of the exterior angle of a triangle is equal to the sum of the remote interior angles. Meaning, to get the measurement of angle 1, you have to get the sum of angle B and angle A. So, if angle A is 90 and angle B is 45, then the measurement of angle 1 is equal to 135. Let us find the measure of angle 1 here. So, angle 1 is one of the remote angles here. Okay, angle 1 is one of the remote angles. And that is what we are looking for. What is given here is the measurement of the exterior angle. So to get the measurement of angle 1, we simply subtract 112 from 131. So we subtract 131 minus 112 is equal to 19 degrees. So measurement of angle 1 here is 19 degrees. For this figure, what we are looking for is an exterior angle. So we add the remote angle, 60 plus 60 is equal to 120 degrees. So angle 1 is equal to 120 degrees. If you see this symbol is for right angle, and right angles are always 90 degrees. So angle 1 is an exterior angle, so we sum up the remote angles. 90 plus 20 is equal to 110 degrees. So we move on to the Pythagorean Theorem. I know that you already know what Pythagorean Theorem is all about, and it is being discovered by Pythagoras. That is the reason why this theorem was named after him. So this is one of the proof of the Pythagorean Theorem. In your own in your assignment, one of your activities to prove Pythagorean Theorem in your own way. Do not research and do not use the other proof by other mathematicians. I want you to discover your original proof of the Pythagorean Theorem. So from this figure, these two squares are congruent, these two squares. And then we place two squares, these two yellow squares, in a big square, and in here we put one big squares. So these Notice that each square has 4 dark green triangles. Yeah, here 1, 2, 3, 4. 1, 2, 3, 4. Therefore, the yellow regions must be equal because these 4 right triangles are equal to one another. So the remaining squares, these 2 squares, if you sum up, is equal to this square. So the yellow area, to get the area of this square, the small square is a square. And then here, that's b squared. And the yellow area of this one is c squared. And we know that the sum of these 2 squares is equal to this yellow square. So we may say that c squared is equal to a squared plus b squared. And that is the Pythagorean Theorem. C squared is equal to a squared plus b squared. And if you are solving for a squared, for a, you use a squared equals c squared minus b squared. Then if you are looking for b, then b squared is equal to c squared minus a squared. So that's Pythagorean Theorem. Take note of your assignment. We move on to the perimeter of a triangle. When we say perimeter, it is the sum of the edges of the given plane figure. So in this triangle, it is the sum of the 3 sides. So to calculate the perimeter of a triangle, you will need to add the sides. So we have here 3, 4, and 5. You add it up, the sum is equal to how many? 7 plus 5 is 12. So the perimeter is 12. That's how easy solving for the perimeter of a triangle. Just look into the edges of the triangle, the outside edges of the triangle, and sum it up to get the perimeter. So find the perimeter of these triangles. We have 5, 5, and 5. So the perimeter is equal to 15. And then we have here 8, 10, and 6. So the perimeter is 24. We have here 3, 4, and 5, the same as what is in the example. So that's 12. 3, 3, and 3. So the perimeter is 9. Tricky perimeters. Please look carefully. If you want to try this type of problem or this problem, please pause this video and try solving this tricky perimeter. And then to check whether your answer is right or wrong, just continue playing the video. You will need to remember which side to add and the values for each side. Take a look. What is the perimeter? So if this is 3, this is 3, then this is 2. What would be this? This is also 2. Then this is also 2 and 2. To get the perimeter, we add 2 plus 2, 4, 6, 8, 10, 12, 14, and then plus 3, 17. So let us double check. We have 2, 4, 6, 8, 10, 12, 14 plus 3 is 17. Do we need to add this side to the perimeter? Yes or no? The answer is no, because this is not an outside edge. If we are solving for the perimeter, we are just adding all the outside edges of the figure. In this case, this edge is not an outside edge. So this is not part of the perimeter. So the perimeter of this figure is only equal to 17 units. Did you get it right? Very. Area of a triangle. We are already done with the perimeter. Let's now move on to the area of a triangle. Find the area of a triangle. Finding the area of a triangle is different. The formula is 1/2 of the base times the height. So we have to identify what is the height and what is the base of the triangle. Take note that the height of the triangle is always perpendicular to the base. In this case, we have a right triangle, so we do not have any problem with solving the area because we already have the height of 3 and a base of 4. So again, the area is 1/2 of the base times the height. So you multiply base and height, 4 times 3, that's 12. And then multiply it by 1/2, 12 times 1/2 is equal to 6. So the area of a triangle is equal to 6. The area of a triangle, sometimes it makes it easier to remember if you can imagine it like this. A triangle is half of a rectangle or square. This is because the base, 4, times the height, 3, would be the same as the length times the width of a rectangle. Right? So if you double this right triangle and you put the other triangle like this, so you'll be forming a rectangle here. And we know that the area of a rectangle is equal to length times the width. And upon looking at it, you'll see that this right triangle is just 1/2 of the rectangle. That is the reason why we divide it by 1/2. Alright. Find the area of these triangles. Once again, if you want to try this problem, just pause this video. And if you want to check your answer, just continue playing the video. This is what I am saying. The base here is 7, since this is not a right triangle. So you have to get the height of the triangle. And the height of the triangle is always perpendicular to the base. So suppose that this height is perpendicular to this base. So this is our height, 7 times 5 is 35. Divided by 2 is equal to 17.5. So the area of this triangle is 17.5 square unit. By the way, in solving for the area, it is always in the square unit. If it is inches, if the given is in inches, then your area is always in the square inches. If your given is in centimeters, then your area is in the square centimeters. So in this figure, 7 times 5 is 35, and then divide it by 2, that is 17.5. Here, we have a right triangle, so we do not have problem with the height and the base. You multiply 8 by 6, that is equal to 48. Divided by 2 is equal to 24. So the area is equal to 24 square units. Here we have 3 and 4. The height is 3 and the base is 4. You multiply 4 by 3 is 12. Divided by 2 is equal to 6. So our area is equal to 6 square units. Here, this is not a right triangle, so we use the base and the height. So 2 times 3 is equal to 6. Divided by 2 is equal to 3 square units. So that is how you solve for the area of the triangle. If you have any more questions with regards to what we discussed this day, just feel free to message me in our group chat, BSE SEM 6, BSE 2B. Once again, thank you very much. God bless and keep safe always.